but we do get reflection in C++6 to some degree.
Nobody is challenging this idea, and nobody is questioning it, as far as I know.
Okay.
You can see it as an enforced contract.
Okay. But modules. We work from is the world where our compilers would just look at us and say, easy.
Right.
I do not have my watch on here. Otherwise, I would look at my watch as if it told me the year. And I would say 2025. That's 5 years now. What happened? What is holding us back? Welcome to The Curious Developer. I'm Jesper Pedersen from KDAP. And in this edition here, I'm very proud to interview Daniela Engert, who is a truly amazing person. I met her the first time at NDC TechTime, which is in my timeline a month or so ago. She came up to me and said, "Hey, you're Jesper Pedersen. You're the guy who I learned all the cute widget stuff from." Which is like, seriously, you are the module person that I still fail to learn modules. But that's on me, not on her. I'll have a good long talk with her today about being in the C++ standard committee, about modules, definitely, and many other things. So stay tuned. So you have been working with C++ for quite a few years. When did it start for you?
When did I start working in C++? I would say 20 years ago, for the most part.
Yeah.
I've been into different languages before. Started with Fortran in my youth time, and over through Basic and other different languages.
Mm-hmm.
I ended up in C++ because the companies that I've been working with were mostly doing their source code in C++ as the major implementation language. This is how I got involved into that and made me interested in to learn the deep stuff in there and from the very ground up. This is how I ended up in this language.
So normal people, that would exclude you in this sentence here. They would go and get themselves a book and learn C++. But,
yeah, this is what I did as well.
But you also are in the stand-up committee. There's got to be some learning in there at least. But
right.
Why are you in the stand-up committee? What does that bring to you?
Yeah, the point is, I was so interested in this kind of stuff, and I'm getting older, as we probably all do. And at a certain point, I was thinking, if I want to mentor my colleagues or new people that coming into our team, I need to be more aware of what is going on in this language, such I can get informed information to them.
Yeah.
This was the first motivation. The next one is I'm really curious about this kind of stuff. And then I took the opportunity just to hop on a train, go to a meeting not too far away from my hometown, happening in Cologne. 4 hours train ride, and I arrived. Hi, you're here. I'm interested in this kind of stuff, and this is how I got into there. And what I learned there is these are very nice people.
Yeah.
Very knowledgeable people. They are kind to me. I'm a totally introvert. I don't want to speak to people that I don't know, but it was so easy to speak to them and to feel at home. And this is how I got into the C++ standards committee.
Okay. So are these meetings open, or do you just join them, or do you...
At this time it was possible. The ISO rules were not as strictly enforced as they are today. So I could just ask the people from the German national body, is it okay to go there and take the chance to do it?
Right.
And I was totally hooked. And it was very nice to see that the next meeting that I could possibly attend to it was just the one that C++20 was finished, and it was even closer to my hometown.
Okay.
So I could show up there and see how it is actually if a particular version of the C++ standard is finished and will see the light of the day. Just the birth of a new version of the standard.
But that's what I don't get. So right now, as we speak here, the C++ standard committee is meeting in Hawaii, right?
In Hawaii,
Yeah.
in Kona.
A free trip to Hawaii. Well, why are you here?
Well, people have possibly a wrong understanding what an ISO meeting would look like. I would never consider to travel around half of the world just to sit for an entire week in the basement of a building, possibly without even a view to the outside, no matter how beautiful it might be, just to talk about technical kinds of things. This is not what a normal person would do. And I don't think this is a good way to spend my time and my money on, because I do everything on my own. I'm not supported by my company.
Can you rewind again?
To spend my time and my money on.
You're paid for going to these meetings, and
Yes.
it's like 3 weeks a year, right?
If I would attend all of the meetings, it would be 3 weeks.
That's like whole summer vacation in Denmark you're spending on C++ standard committee in the year.
This is, yeah, exactly that.
But that's where you give a thumb up in this video, not for my doubtfully very good questioning here, but for Daniela's contribution as a C++. So on behalf of myself and everybody that is watching this, I'm sure, thank you very much for your contribution. That is, sir. That's truly awesome.
If it wouldn't be a joy, I wouldn't do it.
You went to Untitled shortly after you went to, how's that conference in Copenhagen?
It was the C++ user group in Stockholm that invited me to speak there.
Okay.
It was a blast. I really enjoyed it.
Go to semicolon.
And the go-to conference then was in Copenhagen in Denmark.
What is in it for you to go and present at all these conferences?
Yeah, what's in for me? And every time I prepare a talk for presenting at particular opportunities, I learn something by myself. Yeah. Because the best thing to give a talk is go deep into a particular topic and learn. Otherwise, you probably don't have the incentive to do that.
Yeah.
This is one of the reasons why I'm doing it. And the other one is, if I have learned something, I want to spread my knowledge. I mentioned before, I'm trying to mentor young developers, and this is what I can do by speaking at conferences and speaking to other developers in the famous hallway track. This is the most important track at every conference, to actually meet people and speak to them and learn about their particular experiences there. This is why I'm doing it.
Yeah. And once you're done watching this, don't do it now. Once you're done watching this, there's a presentation from CPKeyCon, was that 2 years ago? Contemporary C++ action. Yeah. I watched that on the flight to this interview here. Let me give you a word of warning for those of you that might want to do the same thing. An airplane, not the right place to watch this, because that's way too involving. And do not attempt, as you're doing here, when you are watching this and you're speeding me up to 1.5, as we all do when we're watching stuff on YouTube. Do not do that this presentation. I tried and I had to rewatch quite a bit of it in the hotel last night. But very, very good stuff there, sir.
Thank you very much. I'm pretty happy with this particular presentation, I will say.
Yeah.
And I had the opportunity to coin the term contemporary C++, because after this presentation, Diane picked it up and other people did the same.
Yeah.
Because with contemporary C++, I mean, pick the best parts for debuffing that C++ is offering to us. And not stick to a particular way of thinking about programming. Just learn and retain the best pieces of it And this is what contemporary C++ is all about.
That, of course, picking the right part, isn't that one of the problems? And I'm curious if you have any suggestion in that path. Isn't that one of the problems that we have with C++? It's such an old language. I mean, 40, 50 years old by now or something like that. And there is enormous amount of resources on YouTube or in books or whatever. I mean, I have 3 editions of the same book from Bjarne's Drugstore. I'm sure the first 2 editions are outdated by now, but how do we get over that problem that people will learn from outdated material? They will read books that seems shiny and new and it's from 2017, so it must be contemporary, but we learn so much in those last 8 years.
Yeah, the problem is that in C++ we have so many opportunities to do the same thing in different ways, and what is the best way to do it. And it all depends on your experience. You can't say this is the very best way to do it, but this is probably the best way to do it for you right now. And then maybe if you have the opportunity to watch other people possibly giving talks at conferences, this might interest you into learn about a different way to do the same kind of thing in the first place, but then realize, oh, this is possibly even a better way to do it rather than you're doing it the past 20 years or whatever it has been. So we have a lot of different choices, and with choice comes the question what to choose actually.
Yeah.
So if you are stuck with outdated material, then I can only be sorry with you. Maybe you have heard of other people also in the same kind of business training the users of C++ in a way that you actually improve what you're doing. And outdated material is way too common in my experience, and in my you shouldn't buy the 7th edition of the same book. You should probably look into more recent books.
So if you're watching this video and it's now 2045, do not listen to anything we're saying because it's outdated. If you're watching this in 25 or 26, possibly even 27, it's okay. And definitely go back and watch the contemporary C++ in action, because that is has not aged yet, at least.
I would say it has aged. Contemporary C++ from 2023 is different from the one that we have in 25 now.
Okay.
We have improved a lot in the past 3 years in C++, and as a committee member, I'm always trying to check out if the new stuff that is coming is actually helping me. Can I get some experience from it, and is it actually part what I would consider contemporary C++? And I think there are parts in there that fit into this particular bracket.
So CPP on 2026 will have the now contemporary presentation from you?
Actually, it will be planning a talk for next year, and it will be a succession of that.
Okay. So I'm curious, can you pinpoint particular thing in C++ 26?
Maybe it will be about modules again. But I want to...
Don't worry, we will talk about modules. I got plenty of questions there.
Okay, let's see how it goes. Yeah, I will actually revisit the application that I'm presenting at CPPCon 2022 and want to present it from a different angle with a different use case, and want to show people what you can do right now. This is my current plan. That doesn't mean I will actually perform and execute this plan.
Well, it would be wrong to assume that you do this like, what is it, almost a year out from now, the contemporary thing you, and I know because I saw it yesterday, introduced it by like 10 weeks ago. I was asked for yet another module presentation. I said, no, but I'll do something completely different. So 10 weeks seems like a good planning horizon for a presentation there.
I was thinking about your words.
Yeah, I mean, if you overplan things, that's when it gets too complicated.
Yeah, I'm a perfectionist. I plan ahead quite a lot. And the next conference will be in March.
Oh, cool.
Yeah.
Okay.
I'm planning for this particular conference in Madrid.
Yeah.
I don't know if I get accepted, but
It seems like something I should be planning for too. Denmark in March is no fun. So,
okay.
yeah. So, there are many things in C++,
Yeah.
and we are all at different levels. I mean, I would love to be doing a show here for people that was where I knew exactly what level they were on. Somebody would say, "Oh, that's super trivial. This is not." But if you should pick, say, 3, 4, a handful of things in modern C++, you can define modern yourself, that should be in everybody's toolbox. You give me.
Yeah, what I would recommend to everybody is learn about this new notion of hardening stuff. Now we get in C++ 26 the harden standard library, but this does not only apply to the standard library. You can do it for your own libraries as well. This means if you have precondition in particular functionality of your code, you should actually express these preconditions that you have and put code in your library, for example, a standard library, that these preconditions can be enforced. And this is what a hardened standard library is all about. So, you know, this thing that C++ and or C is portrayed as an unsafe language in contrast to, for example, what Rust does. This is a pretty similar language. But if you harden your code and you actually enforce the preconditions that we always had in C++, but we didn't enforce it, we just called it, if you don't do that, it's undefined behavior.
God, that's undefined behavior. That's what my teenager at home does. That's undefined behavior all the time.
Yeah. We are pretty familiar with undefined behavior. This does only means we don't stick to the rules any longer. And this is where these safety and security function, in particular functional safety problems, are coming from. And we want to rein into that. And this is where this hardening is coming from. This is one of the major.
So just to bring it to a very simple level, so I'm sure I understand what we're talking about here. That is like if I have a vector that's empty and I index it into that vector, that will be usually undefined behavior, and I will be with hardening, I will be
exactly. This is the idea behind it. And if you are particularly in the development cycle of a product, switch it on. Use every tool that you have in your tool set to actually make your product more safe, and don't be surprised about the behavior of your code because you didn't foresee a particular situation.
And in this group, we also have these new pre and post.
Yes, this is where this is now enshrined into the language itself. Right. In the past, we had to make sure that we documented, for example, as source code comments, or we were using particular macros to make sure that we are actually meeting particular expectations about the force of our code.
But aren't they just like asserts?
This is pretty much what they are called. We call it contracts, but actually in the standard they are called assertions. Assertions about a particular state of your code.
Okay. Yeah.
The next thing that I would recommend to look into is all the new vocabulary types that we have in the standard library, and you possibly write some of your own that you use in your company or in your code, and make use of that.
Give me an example.
For example, use spans.
Okay.
Use an optional. Yeah. Use a variant. Don't use the low-level language things that we have. For example, we have pointers. We have pointers pretty much for everything. This is the problem with that. We index into pointers. We should rather use the index operator in a span. Now we can actually enforce our expectations.
So vocabulary types.
Vocabulary types and the algorithms, of course. We had added so much in the past 10 years to the standard library in regards to the algorithms. Now we have the range-based algorithms that fit into the vocabulary types.
Yeah.
So now we have a much, much better place to actually express ourselves in code.
I cannot agree more with you. The algorithm in my personal project, so the project I do in work, it will not follow that the stuff will be scrutinized extra much or what is that. An algorithm that is any of or transform or filter or whatever.
Yeah, it's so easy to express what you really want to do in your code.
Yeah.
You write less code, but it's every line of code that you write expresses more.
My personal observation here, it also requires that you the effort in thinking thoroughly about them. I mean, you're running through something and you're summing up. I mean, accumulate. That might not, and it, even before it was called accumulate in modern C++, it was called.
We still have accumulate, but we now have multiple versions of accumulate according to different expectations how you want to accumulate.
Right. Yeah. See, now I thought it was accumulate. Remember, and the other one I didn't. I see, that's one of those sectors that you need to remember the name. But also, I mean, one of my favorite is IOTA. It's like, you just want to have something and like IOTA pipe it or run it through zip with something and.
Barely anyone is aware of IOTA, I would assume.
Yeah.
Yeah, this is the big. And the last thing I would recommend to look into is compile time programming. Compile time programming is one of the foundations, I would say, in the future of C++. We have constacks where we had template meta programming for a long, long, long time since the inception of the standard in C++. But nowadays it had evolved so much, and if you look into the upcoming C++ feature called reflection, this is compile time reflection. This is completely different to what you have in other languages where you have runtime reflection. This is in some cases not the same thing as.
He's trying to say cute but doesn't want to say it. I can say it for you.
Okay. Yeah, but compile time reflection, and if you go beyond that, now we will get, I hope so, but we have the first glimpse of that already in the proposals. We get compile time code generation. And in cute words, it would be similar to what we have in mock, for example, or the RC compiler.
Yeah.
This is code generation, but we can't do it at compile time. So the compiler is looking at your code, gets instruction how to look at it, how to transform the knowledge that it's gathering from the code, and generates new code and compiles it. This is what the future of C++ will hold.
Yeah.
But not C++ 26, unfortunately.
So 29 earliest?
I would assume we have a much better situation in 29. Yeah. Maybe we get the first parts of code generation in there as well. But this should sound to me like more of 10 years trajectory.
Okay. But we do get reflection in C++ 26 to some degree, right?
Nobody is challenging this idea right now. It's in the draft standard right now, and nobody is questioning it as far as I know.
Okay.
You can see it as an enforced contract.
Okay.
Contracts is more controversial.
Yeah. When you're watching this, the drama, the holding back your breath on will it or will it not be in there will be over, but they are meeting in
Connor right now.
Right. Go.
And we have a lot of discussions, very heated discussions, in the run up to this meeting, and we will see how C++26 will turn out. I really hope we get C++26 for apparent reasons. We can express what we expect from our code, and we can document it. This is what often forgotten. People from the outside of our source code want to look at what we are doing, if we are doing it diligently, if we are really thinking about what we want to achieve and express it in a way. This is really worth doing, this kind of stuff, and this is how we should not rip it out again, in my opinion.
Well, we will know when we watch this, if you weren't noticed. Unless we're giving up on C++26 altogether and maybe C++27.
Oh, I don't think this would not happen, because until C++11, we in the committee had the idea, let's finish a particular piece of the language and ship the new standard if we all agree this is the best way to do it. And you know how things have turned out. C++OX was only a valid notion because we have hexadecimal numbers.
Fair point. Fair point.
Yeah, and now we have adopted this train model, which means every 3 years we try to ship a new version of the standard where we can actually say, okay, this is our train. For the insiders, this is not a DB train. Let's take, for example, a Swiss train. It always goes on time. And everybody who is in the station at this particular piece of time when the train is leaving the station, this will be in the standard. And if we think a particular new feature in the C++ language is not fit to actually enter this train, then it doesn't. We want to make a sure prediction when you will get a new version of the standard, and this is also important for the implementers. Implementers have to plan ahead what kind of resources they have to put into the compiler team, into the library team, and if the implementers don't know what will come out in a particular time frame, they can't plan ahead. And they have customers. At least some of the implementers have customers that paying lots of money. So you need to make sure what you're actually delivering. We as the standard committee, our deliverable is the document that is actually describing what we expect from the implementers.
Let's talk about modules. C++20 had a number of searching for words here. I'm trying to find the biggest word in my vocabulary. Gigantic, fantastic, enormous.
Coroutines,
modules, ranges, I'm sure many other things.
yes.
Some of these couldn't take off. Contracts, that was an easy one. Everybody loves contracts, and it's much more into concepts these days.
Concepts.
Concepts. They are into concepts. Concepts. We say 3 times. Concepts. But modules. We were promised a world where our compilers would just look at us and say, easy, did that last week, it's already compiled. Here is it. Here is the whole standard template library at a breeze of 3 milliseconds. And you want Q2? Well, it's funny because here is another 2 milliseconds and there's your Q.
Right.
I do not have my watch on here. Otherwise, I would look at my watch as if it told me the year, and I would say 2025. That's 5 years now. I mean, go 5 years before 20. That was I was still wearing. No, I was not wearing. I wear mine. No, let's not go there. It's 5 years. It's an enormous long time. What happened? I mean, it's not short of knowing what it is. You have given presentation every year since then on modules. What is holding us back?
Yeah. let me start in a different angle. Modules are not a new idea. It's actually more than 20 years old, this idea.
Okay.
It started when the rise of templates started with the notion of modern C++, this famous book by Andrei Alexandrescu. Maybe you've read about it. And then people noticed C++ is not as simple as it has been the years before. You had this differentiation between this is my interface, this was the header file, and this is my implementation, this is my source file. And the header files were quite simple in the years before. But with the advent of modern C++, people noticed you have to put more and more stuff into the headers. So the headers grew and compilers were dropping. And this is where the ideas of we need to find a better way to actually express our interfaces and what we put in there in a better way. Not as a piece of source code that happens to be in a header file rather than possibly a source file. And this is where the idea of we need to find a way to make this better came from.
Yeah.
And in about, I would say, 2017, there was a technical specification that was formulated in the committee, not yet in the standard itself, but as a technical specification where this idea was laid out in front of possible users, and we also had the first implementations in compilers that were somewhat usable at the time. And this is where I was actually trying to figure out how usable is this new idea of modules. So this was 2027, Clang 7-ish or something like that, and MSVC 2017. And I was immediately hooked by the idea. I could see what the future would bring. And in 2019, when the modules feature was actually merged into the draft C++ standard back then, I learned I could really do something useful with it and actually present it at conferences. This is how that I got involved into presenting all my knowledge that I've gathered in the 2 years before, and I've been presenting it in the years since then. And I actually started using modules in 2021, I would say, in code in our company. It was not just an experiment anymore. It was actually something that I could use. But the problem is, it was just a compiler feature. And modules don't live just from the compiler. It's actually a new kind of thinking how you structure your code. And you need help from the build system.
Right.
And as long as you don't have a build system that actually supports you in this new way of expressing your interfaces and taking advantage of them and taking advantage of precompiling large chunks of your interface such that you can use it later on, this was not a thing in most build systems. And this is still the case in some build systems today. And as you know, most people use CMake nowadays as the standard build system. And for a reason that I don't really understand, modules are not as well supported in CMake as build system as it is, for example, in other build systems. And I'm in the fortunate situation that I can use one of these other build systems, so I can use it in our company code.
Okay, so it's a hen and an egg problem that,
in some sense, yes,
that there's a lot of work for the build system people to support modules, and until they've done that work, nobody can use modules, and therefore people are just like, whatever. And then the build system people
That's the
sure I know what the company behind CMake is called. If you give me a
kitware.
kitware, that way. So the kitware upper management is looking and it's like, nobody's asking for modules. Why would we spend the effort in that?
I wouldn't portray it as in this way. They're actually very much interested in, actually, they have been implementing modules for the Fortran language.
Okay.
Fortran has modules as well.
Okay.
And, but it's not the same as it is in C++. Everything is a little bit more complicated in C++, and this applies to modules just as well. And where most people are probably struggling with is the fact that if you have dependencies in your source code, you usually express it through headers.
Yeah.
And header is a piece of your source code that you lay down in your file system, and it is there. This is how you use it, and this is easy for the build systems. But with modules, the interface that is actually an input to the next compiler translation unit run, the next compiler invocation, this is generated on the fly. So what the compiler is doing is actually generating an artifact that is a dependency of the next translation unit. And this is where the difficulty comes from. You no longer have the dependency to a certain piece of code in your code base that is input into your compilation process. Now this is something that is generated on the fly. Such, you have the code generators in Qt, for example. You have this mock. This is also a dependency. The input into mock is a dependency for the entire program, but what you get out of the code generator is an input for the next compile. So now you need a way to actually express this dependency in some way and make it discoverable. If the build system can't discover these dependency network and these chains, then it is very difficult for them. And this is where some build systems are struggling until today.
Let me try and see if I get this right. And this is the beauty of not sending live here, because we'll just cut out how stupid I am if this is not a valid question. So basically what you're telling me is that in today's world, with includes and stuff like that, the build system can say, screw the compiler, I can read the file, I can build a dependency graph. But with modules in the build system basically needs a full-blown compiler in there to be able to generate that dependency graph.
It needs enough information to actually build this. And what we have discovered after shipping modules, and I'm also a member of the tooling study group in C++, we discovered that we need to express, or we instruct the compilers to actually give us the information such that a build system can learn from it and now can lay out in which order these compiler invocations need to be to actually satisfy these dependencies in between.
Up until a few weeks ago, when I started preparing for this presentation, this interview here, I had the impression that modules was just one of those things that it was a good idea at the time, but it was never gonna get off the ground because it doesn't work beyond simple toy examples. But you actually told me that you have import Qt working.
Yes, I have. Since I would say half a year now.
Okay.
And it is actually a easy thing to do if you know how to do it. Yeah. What is a module? It's just a representation of your interface. So, but when it comes, for example, to Qt, you say, this is the entire interface of a... Qt has modules as well, but it's with a different meaning. And presented to the compiler with a particular compiler flag, and now you get an artifact that represents the entirety of the interface of this particular Qt module. And what I did is speaking about 3 foundational Qt modules. This is Qt Core, Qt UI, and Qt Widgets, and put it into a larger thing. This is what I call import Qt in my situation, and this is just one compiler invocation, and what I get out of it is an artifact, a particular file that I can then reuse whenever I want to use these Qt interfaces in my code. So this is much easier than all this multitude of different and sometimes artificially looking pieces of the interface that you have in Qt.
So you said you have Qt Core, Qt GUI, Qt Widgets.
Yes.
So in the other spawn, that just more of the same work, or is
I didn't look into them. It's just the same.
And I'm just trying to visualize here for my inner eye. What kind of work is that? Is that adding a few extra files, or are you modifying the source of every single Qt file?
In my case, it's to actually generate this artifact that I've been speaking before. This is a sync file where I just say #include core, #include GUI, #include widgets. I could also say #include QML, #include whatever you want from the framework. It is a framework. And give it to my compiler, and the compiler will spit out this artifact. So it's, from this particular point of view, just more of the same.
This is where I'll look like this, as if I'm looking into the future, boss. I'd like you to look into the future with me. I don't know if this future is 2026 or 2029 or whatever it's now. The future is now. Never. But this particular future I'm talking about, where I, as a regular Qt developer, and sorry for those of you that are not into Qt, but just take your favorite library and think of that when I say Qt. Certainly place in the subtypes. So in the future, where as a regular Qt developer, not working for the Qt company, not working anywhere fancy, I have my own 3-man shop, and I go and download the Qt SDK, which comes with all the Qt libraries precompiled for me, and with particular flags for whatever their preferred thing is, and I'll compile my software with my flags and link against the Qt that are shipped in the SDK. Will there in them be also a gizmo or whatever precompiled?
Now we're at the heart of the problem with modules. So you were mentioning...
Even a blind hen can find a corner.
You mentioned you ship a precompiled stuff.
Yeah.
A piece of code. This is what you can't do with modules.
Okay.
And this is what people struggling with. What we give with modules is a way to express how to precompile the stuff that you want to use in your particular situation for yourself, with your set of compiler flags.
Okay.
And this is the key insight that we have. You can no longer ship, for example, precompiled binaries of Qt. You cannot ship a precompiled module with all the interfaces of Qt. In particular, when it comes to the interfaces, you need to compile it on your own. What you can ship is, for example, the source code with the recipe, how people can compile it in their own environment. And now put them aside. This is in my storage where I can grab into if I want to use Qt then. But you need to do that by yourself.
Interesting. So is this going to be the year of the modules?
I hope so, but I'm not really sure about it, because if you would like to ship this particular recipe, then people will ask you, can I do it in CMake? And then the answer would be, unfortunately not. because I was mentioning not every build system or build tool is actually capable of do this kind of thing that you will want to do. But for the users, it would be a huge improvement, I would say. It's much easier to import Qt than, for example, a Qt core application or whatever you actually did right now in this particular situation.
Yeah. Well, funny enough, I was playing with ranges yesterday, and had some code written somewhere, and I copied it over to somewhere else. And I could, for the love of my creator, not get it working. And it turned out that I can't even remember what path it was an algorithm rather than ranges. I mean, I would have loved to write import std, be done with it, just everything works.
You mentioned this accumulate algorithm earlier in this interview here, and most people would assume accumulating stuff, this is an algorithm. No, it's not. It's in a numerics header. So discoverability of APIs is a huge hurdle for newcomers to a language. If you can use it with a module, and in particular what I recommend, use large modules, use Qt module, use the standard module, use whatever big thing you can build a module from, use that rather than chopping it into small pieces, and now you add the discoverability problem once again.
I'm looking into my future in here. Will I take my own software and make that into modules, or will they still be including my utility stuff over there where I do something that I want to repeat to?
I would love to say you would only be using modules, but unfortunately we are not there yet. I'm doing it in my own source code at the company, both using include files and modules. What I try to do, use modules because modules are faster in most cases. You can generalize it, but it usually is faster. And now you have a consistent piece of code that you don't split artificially into smaller pieces that you shouldn't probably do. But you can't do this in every case, and you need to be aware you're part of a team. And if you're in a team and not everybody is actually sold on a particular new feature in a language, then you probably shouldn't do it.
I saw multiple of your presentations in preparation for this, and in one of those you were showing import std, and you had some simple example, and you said, here I include, here I import, here we have 100,000 lines of code that your compiler would need to go through, because just import and I was about to say standard it out anything, and you get lots and lots of stuff in. Import, you get 3 lines in, and you showed here we have 1.6 seconds, here we have 22 milliseconds.
Oh, this famous word.
Just making up numbers. But the key thing is, I am obviously not only including or importing stuff in my software, I'm writing my own stuff that the compiler still needs to see and understand. So are we all walking around saying, oh, our code is nowadays taking an hour to compile, but 1 second down to 10 milliseconds, that means a factor of, and my code will now be compiling in no time. I won't have time for coffee anymore. Or do you have any from your own experience from for what we're talking about?
I have an opinion at that. This is a misportrayal if you expect huge amounts of improvements in compile speed from modules. This is not the case. Modules were never meant to improve your compilation speed.
Yeah.
Modules are only about packaging your interfaces much better than you can do it with include files. Improved compilation speed is just a side effect. Sometimes the side effects can be huge. And if you as you mentioned this particular slide from the formatting library where I was presenting, this is how quick it would be to actually make this interface of the formatting library available to your source code that you actually want to do. You don't want to implement the formatting library, you want to use it. And this is how quick it could be if you had a module called FMT, and you saw was 5 orders of magnitude in between that. This is a huge difference. But our source code is not only about bringing interfaces into our translation unit, it's actually using it. And the usage part in your translation unit is not sped up by using a module. It's just about how quick it is to bring an interface into a translation unit. And this can be really, really, really huge. This was the reason why I was using on introducing modules in a particular project in our company, and it was late 2021, early 22, and we had a predecessor code that we had to improve for the next project. That compilation times of 20 minutes. You can't go out to the customer, fix a particular or implement a new feature in there, and then you go away and compile it for 20 minutes and now see, oh, this was not the correct answer to this new question that the customer is having. So our turnaround times needed to improve a lot. You can't bring out a new version of a particular project if you have such long compilation times. We could buy new development machines. We did. We got a 2 times improvement from that. But 10 minutes is still way too long. This is not an affordable compilation cycle at the developer desk, I would say. And then I set out, okay, let's look at this particular piece of code, introduce modules in a very, I would say, inventive way. And this brought the compilation time down by a factor of 1000%. So it was just 1 minute instead of 10.
Wow. My dog is going to be unhappy if I don't have all that time where I'm sitting there waiting for my compiler and the feature time. Yeah, just waiting for the compiler. But then, unfortunately, I have const expression that can make my compiler do a lot of work.
Yeah, and this 1 minute compilation time was the entire software for this machine. It's not just a small feature. What I mean, if large pieces of your actual code is precompiled and then cached and reused by the compiler, your development cycle will be much, much, much faster. Even if you are only dealing with a small part of the application. So this is where you get the benefits from when it comes to compile throughput. But it depends on how you structure your code.
That's how all these interviews end. Well, it depends. It was a true pleasure. It was a pleasure to talk to you. Thank you very much.
Thank you too.